In quantum mechanics, the terms observation and measurement are often used interchangeably, but they can have subtle distinctions depending on the context and interpretation being discussed. Here's a detailed breakdown. 1. Traditional view, Copenhagen interpretation. Observation and measurement are closely related and often treated as the same thing. Both refer to any interaction with a system that extracts information about it. In the double-slit experiment, placing a device to detect which slit the particle goes through is considered a measurement. This act of measuring collapses the wave function and forces the particle into a definite state, particle-like behavior. The key idea is not about conscious observation but rather the physical interaction between the particle and the measuring apparatus, which disturbs the system and changes its state. 2. Nuances in terminology. Observation. This term sometimes implies a broader concept, including the idea of human awareness or the act of looking at the data. In some interpretations, observation is tied to a conscious observer, though this view is controversial and not universally accepted. Measurement. This is more specific and technical, referring to the interaction between the quantum system and a measuring device that records or extracts information, regardless of whether a human is involved. 3. Modern understanding. In modern quantum mechanics, what causes the transition from a wave-like superposition to a particle-like state, commonly referred to as wave function collapse, is the interaction of the quantum system with an external system, the measuring apparatus. This interaction is often described as decoherence, where the quantum system becomes entangled with the environment or measuring device, effectively losing its coherence as a superposition. Decoherence explains why quantum effects like interference disappear when measurements are made, without necessarily invoking a conscious observer. The distinction between observation and measurement fades here, as the key factor is the interaction, not whether someone is watching. 4. Does the device cause the change? Yes, in most interpretations of quantum mechanics, it is the interaction with the measuring device, not the device's mere presence or the conscious observation of its readings, that causes the collapse of the wave function. This interaction fundamentally alters the state of the quantum system. Summary. Observation and measurement often refer to the same process, an interaction with a quantum system that extracts information and disrupts its superposition. The measuring device, or environment, is what causes the transition from wave-like to particle-like behavior, not the act of human observation per se. In the Copenhagen interpretation, the emphasis is on the collapse of the wave function due to measurement, while other interpretations like decoherence theory provide a more detailed physical explanation of the process.